Alright guys, today we're going to make a Breakout clone with procedural level generation and increasing difficulty. Let's go. Okay, so to start with here, let's create a character body 2D. You'll see over here I've got 3 folders created, assets, scenes, and scripts, and then I've got my images for my sprites in the assets folder. And you can download the full project file from a link in the description. So our character body 2D here is going to be our paddle. So we'll go ahead and rename that paddle. We're going to need 2 other nodes here. We're going to need a sprite 2D, and we are going to need a collision shape 2D. This is just going to allow our paddle to interact with our ball. So for our sprite, let's go ahead and drag our paddle PNG in. And we're going to want to scale this down some. So let's just go ahead and 0.3, 0.3. We can zoom in. And we have a paddle. Now, to make our paddle work, we're going to need to hook up some controls. So we'll click over here on paddle and then go up to add a script. We'll make sure we put this in our scripts folder and we'll call it paddle. And this is going to use the character body 2D basic movement template. So we can go ahead and just create. And that's going to give us this nice function here. Now we don't need to jump and we don't need any gravity. So we can just pull these right out and our jump velocity can go as well. Now all we need to do is set our speed to 1000 and save. We'll save this in our scenes folder as paddle. We'll also want to go ahead and create our level. So we can just come up here and go 2D scene. And we'll call this level. Hop over into 2D mode, reposition, and we're going to need a camera. So let's drop a camera 2D in there. Just for ease of use with our UI, we can drag this down to match our blue lines here. So you can see we have the blue line represents our viewport. And so we'll just drag our camera right on top of it so everything's lined up. And then we can come over to scenes and we will drag our paddle into our level and put it about right there. All right, let's give this a shot and see where we are. This is asking us just to save our scene and choose it as the default. And now if we hit the left and right arrow keys, we can move our paddle around. Awesome. The next thing we'll want to do is create our ball. So we'll just click the plus sign up here to create a new scene. We'll also do this as a character 2D because that gives us extra functions for movement that we wouldn't have in a regular rigid body 2D. We can go ahead and call this ball. And for the ball, we're going to need a sprite again. So sprite 2D, and we'll need a collision shape. For our sprite, we'll come over here, and for our texture, we want to just drag in ball.png. And for our transform on this, we're going to scale it to 0.1 and 0.1. And that will give us what we want. Now for our ball, we're going to add a script. And we'll put this in our scripts folder. And create. And let's just go ahead and just save this scene as ball in our scenes folder as well before we get started here. So a lot of this we don't need. We can just kind of delete all of this stuff and go ahead and define some new variables. So we're going to need a ball speed. We'll set that to 200. We're going to need a direction so that we know what's up and what's down. And we'll call that vector2 dot down. And then we're also going to have a flag for is active, and we'll just set that to true by default because our ball is going to be on the screen when we start. For our ready function, this will run when the ball first enters the scene, so when the scene loads. We want to set the ball's velocity equal to vector2 speed times -1 for our x value and speed for our y value. So what this is going to do is set the velocity of the ball to be going down and to the left at an angle based on our speed value. in order to actually move the ball, we need to give it some logic around how this is going to load every frame. So for this, we're going to use a physics process, and this just this is sort of like a late update. It, instead of using a regular process function here that would run every frame, this runs based on physics collisions. So it's a little more accurate since we're dealing with colliding ball and paddle. So we only want to move our ball if it's active. So we'll say if is active, and then we want to get collision data whenever it collides. So here we're going to say move and collide, and velocity times delta. So what this does is it moves the ball each frame based on delta time. And because we're using move and collide instead of move and slide, which is a little more commonly used, I think, the collision data is actually returned to us. So we can do some cool stuff with that. So we want to say if collision, then velocity equals, and this is when the ball collides with the paddle, we want to get the bounce direction. So to do that, we use collision dot get normal. And this will give us the bounce direction for our ball and set the velocity to go the opposite direction. So sometimes our ball might stall a little bit. So when you have a ball bouncing around the screen, maybe it gets stuck going up and down on the y-axis, or it gets stuck going left and right on the x-axis. So we want to give it some parameters around that, some minimums that we're okay with. So we can say if velocity dot y is greater than 0 and velocity dot y is less than 100, then we want to set velocity dot y equal to minus 200. And the way that the y-axis works in Godot, the negatives go up and the positives go down. So this is basically saying if our velocity y is too low, then let's just kind of shoot it up in the air a little bit. We can do the same thing for our x. So if velocity dot x is equal to 0, that means it's just stuck going up and down, then velocity dot x minus 200 equals minus 200. Okay, so one thing we want to do is in project settings under window, we want to change our mode to canvas items. And what that will do is that will make our game load properly inside the frame. So real quick, before we test this out, let's make sure we have our collider set. So if we come back to our paddle, we'll see that we've got this little arrow here, and that means we need to set up a capsule shape, and we can just drag this like this. We'll click up here to rotate. We'll rotate it to the side like that. Try to get it as straight as you can. And then we'll grab this little handle, pull it out, and sort of size it around our paddle. All right, so this is going to give us a collider so that when the ball comes and hits, and if you want to just come over here and just make sure that your transform is exactly 90 degrees, just so we have a straight line, we'll save that. And then we also need to do the same thing for our ball. So for our collision shape here, we'll go ahead and add a circle collision. We'll just draw this right around our ball. We can hit save, and let's see what we've got. All right. So you can see here that the ball pushed the paddle out of the way. So if you hit your paddle and it flies off the screen like that, you just want to make sure and come up to motion mode on your paddle mode and change grounded to floating. And then that should solve that for you. So you can move your paddle around and your ball will bounce off of it. So now we need to go back to our level, and we're going to create a new node that is a static body 2D. And we'll call this walls. And what we're going to do is we're going to create some walls for our level so that our ball can bounce around. So if we come back over to 2D, we can come in and add a collision shape 2D. And we will call this one left wall. For this, we'll create a rectangle shape, And we can just drag it right down and then pull it sort of even with the edge of our screen. We'll create another. We'll call this one right wall. Again, we'll use a rectangle shape 2D. We'll drag it down to the same height and we'll put it on the other side. And then we also need a ceiling. So we'll do the same thing, collision shape 2D. We'll call this one ceiling. Use a rectangle and we'll just drag it right across the top and then pull it to the edge of the screen. Now our ball shouldn't fly off the screen. There we have it. Now that we have the basics working for our game, let's add some bricks. So come up here, click plus. We're going to click other node, and we want this to be a rigid body 2D. We'll need a sprite. We'll also need a collision shape. So let's go ahead and load up our sprite, grab brick, and we'll drop it into the texture slot. We'll go ahead and set our scale to 0.5, 0.5, and then for our collision shape, we'll do a rectangle shape, and we'll just drag it right around the edges of our brick. We'll call this brick, and we'll go ahead and save it in our scenes folder. Now we need to add a script to our brick. We'll go to our scripts folder, click open, and then create. So we really only need one function here, and we'll call that hit. So when the ball hits our brick, we want to do a couple of things. We want to disable our collider and our sprite. So we can pull these in here. We'll set our sprite visible equal to false. And we will set our collider dot disabled equals to true. And what this will do is it'll make the brick disappear and then disable the collider. We're going to add some effects to our block later, and so we want to make sure that the brick isn't going to stick around and get hit by our ball again. Now we want to wait about a second before we remove our block. So we'll say await, get tree, create timer, and this will be for 1 second, dot timeout. And then queue free will delete our block from existence. Last thing we want to do is come over to our brick, and we want to set our gravity scale to 0 so that our brick doesn't fall off the screen. So the next step is going to be to go over to our ball, and in our ball function, we want to make sure that right here where we're grabbing our collision, we want to say if collision dot get collider dot has method hit collision dot get collider dot hit. And what this will do is this will call the hit function on our brick when the ball hits it. Right. And we want to make sure that this is indented properly so that it's underneath the if conditional. And we can just grab this and bring it up right underneath our conditional here so that we are only doing this on collision. So we'll come back over to our level and drop our brick in. Try to put him about where he'll get hit by the ball, and let's see. There we go, our brick disappeared. So we can go ahead and pull this brick out of our level now, and we'll just save. And now we want to set up our actual procedural generation for our level. So we have a brick, and we'll come up and create a script for our level. Make sure we put this in our scripts folder, open, and create. Okay, so first things first, we need a reference to our brick. So we'll set this up as an onReady var brick object, and then we need to preload that scene. So to do that, we grab the brick down here and we just drag it in right there, and now we have a reference to our brick object. So for our grid, we need to set a number of columns. So we'll set this equal to 32. We need to set a number of rows. We'll make that 7. And then we need a margin around the edges so all of our bricks aren't right up next to the edge of the screen. So on ready, we want to call a function called setupLevel. And let's define that function here. So we'll create a loop to instantiate all of our bricks. And so we need to go through each row, and then we also need to go through each column. And so this is 2 loops inside of each other that basically iterates through all of our rows, and then for each row, we go through each column. For this, we need to create a new brick, and that's going to be brickObject.instantiate. And what this does is actually creates the object in the game. So we want to add this as a child to our level. So new brick. And then we need to position it. So new brick dot position equals, and this will be a vector 2 because it's got X and Y coordinates. And for this, we want to skip our margin. So we got some space on the side of the screen. And then we need to do 34 times C. And that gives us 34 pixels for each column, which is about 2 pixels higher than our brick's size. So it's a 64 pixel brick. We've sized it down by half, so that's 32, and we want to give it a little bit of room in between each brick. So again, we'll do, for our Y, we'll do margin plus, and then 34 times R, and that will give us the same thing, but for our rows. All right, let's see what we get. Okay. So here we have a grid of bricks, and this is cool. We can hit our ball, and this is where we're first starting to see that this could be an actual game. So now let's make it so that each level is a little bit different. So to do this, we're going to generate a random number. And to do that in Godot, we use the rand_i range, and this will give us a random integer in a range of values. So for this, we're going to do between 0 and 2. So this will return either 0, 1, or 2. And then we can say if random number is greater than 0, then instantiate a brick. So now, each time the level loads, it should look slightly different. So see how we're missing some bricks here, and then each time we load this level, it's going to look slightly different than the time before. Pretty cool. So the last thing we want to do is kind of make our bricks look a little bit prettier. So for this, we want to create a new function down here called getColors. And we're going to set up an array of colors that will be returned when we call it. And the way you can set up colors in Godot, you use RGB values and a color object. And I will also link to the page on the Godot reference that has a bunch of different colors that you can just sort of copy and paste. For this, we're going to do a few different colors that I've picked out ahead of time. If you want to use these colors, you can, or you can pick your own. Save that. Now that we have our getColors function, we can actually call it up here. So once we create our brick, then we need to get a reference to our sprite. So that will be inside the new brick object. We will get node, and that will be a sprite 2D. Now, we can set this up by rows. So basically, if row is less than or equal to 9, then we want to call modulate equals colors 0. If R is less than 6, we're going to copy this, and we'll paste it right here, and we'll do colors 1, and that's gonna basically get our next color. And then if it's less than 3, we'll do colors 2. And what this error is saying is that we don't have a reference to colors yet, which fair enough, we don't. So we're gonna scroll up above our loops, and we'll call get colors. And then so our colors are a little bit different every time. We can actually shuffle this with the shuffle function. So now when we run our scene, we'll see that the colors get generated automatically. And each time it's going to be slightly different. Now this purple on this gray is starting to be an eyesore. So let's go ahead back to our 2D view for our level. And we can drag in our background. And we'll also go up to project settings and to environment. And we can just make our background be black. And then for our ordering here, we'll bring it down so that it's behind everything. And then we can go to visibility, modulate, and we'll drop our alpha down so it's pretty dark. Now this is going to give us a little bit nicer feel to the level. And we're really starting to get a game sort of feel going on here with our different colored blocks and our paddle and our bouncing ball. We're getting close. So the next thing we want to do is we want to pop over to our level and we want to add an area 2D. And we will call this death zone. And this is just going to catch our ball. We'll add a collider. So if our ball goes past the paddle, we want to restart our level. So we can add a rectangular shaped collider. We'll drag this out. We want to make sure we're not touching anything else, so we can just keep that right inside the lines there and drag it down right below there. So we'll save that. Come over to our scripts and we'll go to our ball script. So here, we'll make sure we have our death zone selected. And then we can say on body entered. Make sure we've selected our ball and hit connect. And that's going to give us this cool little function here that will be triggered when our ball crosses into the death zone. And we want to trigger a method called game over, which we can define here. And to restart our scene, we want to get tree .reload current scene. Now if our ball goes into our death zone, it should start us over and show us a new level. And there we go. Each time it goes in, it generates a new level and we start over. So no game is fun without a score. So let's go ahead and create a new object here and we'll just make this a regular node. We'll call it game manager. We can save this into our scenes folder and we will add a script in our scripts folder called game manager. For our game manager, we're going to want a score and we're going to want a level. Then we need a function here that we can call from elsewhere in our game to add points. And we will accept an argument of the number of points. And all we're going to do is plus equals points. And we can save. If we hop over into our 2D view, we can add a canvas layer, and this will be for our user interface, so our HUD. And then we need a couple of labels, so we can go label, label, and this will be our score label. And this will be our level label. So for our score, we'll come over into the inspector and we'll give it a default value of 0. We'll horizontally align it to the center. And then for our theme overrides, we can come into font sizes and we'll give it 30. And we can just drag it right down here and give it a little bit of width so our score can get really large. We'll do the same thing with our level. Theme overrides, font sizes 30. We'll give this a default of level 1 so we can see where it goes. And we want this horizontally aligned to the right. And then we'll actually delete that so we can make sure that it's working in our script. So if we come back over to our script view, we need a process function to keep those values updated. So here we want to grab our score label and make sure that we're setting text equal to, and this is a string, so we need to cast our score as a string since it's normally a number. And then we can do the same thing here, dot text equals level plus string level. And so this should keep our UI updated with our current score and our current level at all times. So the last step is to come up to our project settings and go to auto load, because we want our game manager to stay loaded even when we refresh our scene. We'll come into scenes, we'll select game manager, open, and add. And now you can see we have this game manager here that we can access anywhere else in our game. So let's come over to our brick. And here, when our brick is hit, we know it's going to be deleted. So we want to add points, and we'll just add 1 point for each brick that we hit. The next thing we want to do is we want to make sure that we have bricks left. So we need to count our bricks. To do that, we'll do get tree dot get nodes in group brick, and we need to make sure that our brick is actually in a group. So we'll come over to node groups, and it's not, so we'll hit the plus sign, go brick, global, and OK. Now our bricks are all in this group brick. So if bricks left dot size equals 1, meaning this is the last brick that we have on the screen, then we want to get parent dot get node, and this is to get the ball, and we're going to set is active equal to false, and that's going to stop the ball from moving. So what we don't want to do is we don't want to we hit our last brick, we wait a second to load the scene, and the ball keeps going and it can go into that death zone. So we want to stop the ball from moving first. Then we can get our tree. We can create a timer for 1 second, and we'll time out. And then game manager dot level plus equals 1, and that will take us to the next level. And then we can get tree reload current scene. Else, meaning there are more bricks left, we want to wait 1 second and then remove our brick. So essentially, we're handling 2 conditions. It's either the last brick, in which case we go to the next level and reload the scene, or it's not the last brick, in which case we just delete the brick from the scene completely. So let's try that out. All right, we're getting points for our bricks being hit. Great. And our level is also updating down in the bottom right. So now let's make this be a little more interesting based on what level you are. So one thing we can do is we can head over to our ball, and then here where we're setting our velocity, we can also update our speed and say speed equals speed plus 20 times game manager dot level. And this will make the ball go faster and faster depending on what level you're at. And then we also want to come over here to our game over method and set game manager dot score equals to 0 and game manager dot level equals to 1 before we reload that scene. And that'll just reset everything when we die so that we're starting over from a fresh game. In our level script here, right above where we set our colors, we can actually set our rows. So we'll say rows equals to 2 plus game manager dot level, and this will basically mean on level 1 you've got 3 rows, on level 2 you've got 4 rows, and so on. But we need to cap that. So if rows is greater than 9, then make rows equal to 9, and this will ensure that we only ever have 9 rows. If we see here we're at level 1, so if we play, we only have 3 rows. and our ball is going fairly slow. But if we set this to level 10, we now have 9 rows and our ball is going much faster. So the more levels that you have, the faster your ball will go and the more rows you'll have, up to 9 rows, because once you get to a certain point, it becomes impossible to play. So we want to keep that ball speeding up, but not give them so many rows that they can't play it anymore. So now let's go back to our ball. We'll go into 2D view and we can add a new child node, and we'll call this one CPU particles 2D. And you can see this is already kind of shooting some stuff out. So this is going to help make our ball look a lot nicer when it's traveling around the screen. So what we can do is we can go ahead and set our amount to 1,000. For our time, let's go for our lifetime, let's go 0.4. Under drawing, for our texture, we can just use our ball texture again, actually. That's huge though, so we want to come down to scale, and let's set that to 0 to 0.02. And that's a lot nicer size to work with. We can create a new curve here for our scale. And we will start out large, and then we will get really small as we're going through. For our emission shape, we want to select sphere. And then for our sphere radius, we can go about 12. That's kind of cool looking. And then let's give it some color. So we'll go down to color, new gradient, and then instead of black, let's pick like a purplish color and fade that into white. Okay, that's pretty cool. And then for our ordering, we want to make sure that our sprite 2D ordering is 1. And then we can set our CPU particles ordering to 0. And that's going to give us this cool sort of effect where it's behind it. If you want to reduce the sphere size a little bit, we could go to like to 10, and that'll get it from showing around the edges there. Last thing we want to do is come up to gravity, and we want to turn off our gravity, so gravity's not pulling on the particles all the time. Also come in here to visibility and just drop the alpha down on it. See what that looks like. Sweet. All right. So next we'll come over to our brick and we'll do something similar here. We'll go ahead and create a child node, call CPU particles 2D. For this, we want to set our amount to 50, our lifetime to 0.5. We'll make this be a one shot, and we want to pre-process 0.5. We'll turn our randomness all the way up to 1. For our draw order, we'll set that from index to lifetime. Emission shape, we want a sphere. We'll make it be about 24. For gravity, we'll do negative 500. For linear acceleration, we'll set that to 0.1 and 0.1. For our scale, we'll go from 0 to 2. And then for our color, we'll do another color ramp gradient. And we'll set this to a purplish color. So you can see here, when we trigger emitting, we're getting these little particles that pop out of our block. Well, this is going to be what we trigger when our block is totally disabled. So to do that, we come over to our block script, and then right here where we're setting our sprite to be invisible, we can drag in our CPU particles, and we'll say emitting equals true. And since we've got this as one shot, all we have to worry about is turning it on. It'll turn itself off. So when we hit a block now, we should see a little sparkle when the block disappears. All right, there we go, pretty nice. Lastly, let's just come over here and make sure we set our level back to 1 so that we are starting on level 1 when we play the game. And there you go, guys. We have a fully functioning game, and every time someone beats a level, it will get slightly harder, and there are infinite number of procedural levels that can be generated using this technique. If you found this useful or have any questions, please let me know in the comments, and thanks for watching.